Welcome to Chapter 3, Algebraic Expressions and Properties. In this chapter, you'll see that there are 4 sections. We have 3.1, which is algebraic expressions. 3.2 is writing expressions. 3.3 is properties of addition and multiplication. 3.4 is a distributive property. And there is an extension on 3.4 called factoring expressions. So technically there are 5 sections to this one. And we're going to start with 3.1, algebraic expressions. Okay, 3.1, algebraic expressions. To start off, you have to understand what an algebraic expression actually is. So there are a couple of vocab words I want you to write down, so kind of follow with me as I write this. An algebraic expression is an expression that may contain numbers, operations, and one or more symbols. So now we're talking about any of our normal numbers that we talk about, 1, 2, 3, 4, 5. Operations, meaning adding, subtracting, multiplying, dividing. And now we are talking about symbols, and what we're going to start off with is variables, and I'm going to show you that in a second. Parts of an algebraic expression are called terms, and that's what I'm about to show you are what the terms look like. So this is our first algebraic expression. It reads like this: 5p plus 4. The 5 is called a coefficient. So it's the numerical factor of a term that contains a variable, and that's called a coefficient. Now, you're going to have to know that's what that's called. And what I always try to tell kids is, remember, it's the number that's attached to the letter or what we call the variable. So like I said, a variable is a symbol that represents one or more numbers. And that's what I have right here is the variable. So anytime you see a letter, that is now what we call a variable. So I have 5p plus 4. So my coefficient is my 5 because it's attached to my letter, which is my variable. Then I have my operation, and then I have my 4. So that brings me to my 4. So a term without a variable is called a constant. So when you look at a number that's in an algebraic expression and it doesn't have anything attached to it, it's all by itself, that's what we call a constant. So just a quick recap here. We've got our numerical factor that contains a variable, so it has a variable attached to it. And that's right here. We have 5p, so our 5 becomes our coefficient. Our p is our variable. And then our 4 that has no variable connected to it at all is called our constant. And remember, 5p plus 4. These three, well, I guess they're called terms. That's what I want to tell you, is that they're called terms. So 5 is a term, p is a term, and 4 is a term. But they all have different meanings, and you need to know the differences. Example 1 is identifying parts of an algebraic expression, and this pretty much just kind of goes off of what we just learned. Our directions would read something like this: identify the terms, coefficients, and constants in each expression. If I had 5x plus 13, I want to know what my terms are, what my coefficients are, and what my constants are. So this is how I'd want you to write it out. This can be a little confusing, so pay attention. Remember when we talked about terms, terms were all those things: the variable, the coefficients, and the constants. So if I'm looking at terms in this respect, my first term in this would be 5x because it's together. My second term would be 13. Now my coefficients, if you remember, a coefficient is the numerical factor of the term that contains a variable. So which factor contains a variable? The 5x. So the only part that's coefficient is the 5. Remember, it's the numerical, or the number, that goes along with the variable. And then my constants are anything without a variable. So my constant in this situation would be 13. So this one's not too hard, but the next one gets a little bit more difficult. Okay, so I got this one set up, so if you need to pause it to get it set up, go ahead. So I have 2z squared plus y plus 3. I'm going to start off with my terms. Now be careful on this one because it's everything that's kind of attached together. So my first term is 2z squared. That's all one term. My second term, now this one gets a little confusing. I've got a y here. This y, how many y's are there? Well, it's indicating that there's only one. So because there's one, you put 1y. And then I also have 3. Now this is why you write out your terms every time. Because what happens is now I look at my coefficients, and remembering that my coefficient's the numerical factor of a term that contains a variable. Well, right now, I've got one coefficient here because I've got 2 connected to my z. So my first coefficient is 2. My second coefficient, and the reason why I pointed this out, that there's one y, is there's a 1 connected to the y. Just because it's not in the actual expression doesn't mean it's not there. It's technically 1 times whatever y would equal. Let's say that y equals 3. 1 times 3 is still 3. So we have to add that as a coefficient. So we also have 1 as a coefficient. That one can be really tricky. And then my constants, the only thing I have as a constant is a 3, because my constant is a term without a variable. All right, we're going to do one more together. Go ahead and pause it and get this written down. But we have z squared plus 9z. So I'm going to figure out what are my terms to start off with here. Well, just looking at the problem, you can see that I've got z squared, and I also have 9z. So now that I have my terms laid out, now I need to look at what are my coefficients. Well, as I told you before, if I have z by itself or any variable by itself, that means I technically have 1z. So, technically speaking, I have one coefficient, and then I also have 9 as a coefficient because they're both the numbers that are attached to a variable. Now I look up here and I know I have to look for my constants. What are my constants in this scenario? So constant, remember, is a term without a variable. Well, there are no terms without variables. So my answer for constants will be none, because there aren't any in this situation. I always have kids that will ask, do we have to write out terms? Do we have to write out coefficients and constants every time? For practice to start with, yes, you do, because you need to learn. A lot of kids like to put a CO or a CO, and then they get confused over coefficients and constants. So please make sure for now you're writing those out. Example 2 is writing algebraic expressions using exponents. Alright, so the directions would be like, write each expression using exponents, and this would be what one of your questions would read. So just like if we were using numbers, we have d times d times d times d, and notice how we're using the dot in the middle? That's representing our multiplication sign, because if you look back a couple of examples, there was an x used, so we're not going to use the x anymore. So because d is used as a factor 4 times, its exponent is 4. So this would simply just equal d, that's a terrible form, there we go, to the 4th power. Let's try another one. So I have 1 5/10 times h times h times h. So remember, we can take our number 1 5/10 times h. We do not any longer have to put a multiplication sign in there, and we're using h as a factor 3 times, so its exponent becomes 3. So my new term is 1 5/10 h to the 3rd power. Okay, we're going to stop the video here, and we have a few more examples to do after this one, but this was long enough, and that's it for you today.